Hi there, Mr. Sutton here, bringing you the AB Calculus 514 Extra Practice number 5 solutions on integration by substitution with indefinite integrals. On this problem, it helps to realize that we have an inner function that gets repeated here, this 4 minus ln of 3x, and also that the derivative of that inner function, something involving an x, is elsewhere in the problem. So U substitution has a shot on this one. So let's start by letting u equal 4 minus ln of 3x. And then du, the derivative of that, is going to be, well, let's see here, derivative of 4 is 0. And this is going to be negative 1 over 3x times the tail of 3. So negative 1 over x dx. Multiplying to get that stuff over to the other side and isolate dx, we have negative x du being equivalent to dx. Plugging all that back in now, we've got negative 2 cosecant of u, cotan of u, all that over x, and instead of dx we have negative x du. So these x's are going to cancel. The negatives actually cancel too, so that's kind of nice. We just end up with 2 cosecant of u, cotan of u du. And the antiderivative of that is just going to be negative 2 cosecant of u plus c. And we can plug this 4 minus ln of 3x stuff back in for u at the very end. This antiderivative looks like it's going to be kind of wild. The key on this one is recognizing that we have an inner function, tan of negative 5x, whose derivative, secant squared of negative 5x and some change, is elsewhere in the function. So let's try a little u substitution for this one. Let's start by letting u equal tan of negative 5x. So then du is going to be negative 5 secant squared of negative 5x dx. And then dividing by all that to get dx by itself, we have du over all that. Now we can substitute back into the original. So this is going to be 10 secant squared of negative 5x times secant squared of u. And then instead of dx, we have du over all that stuff. All right, let's hope something good happens here. Well, it looks like the secant squared of negative 5x can cancel out. We have a 10 over negative 5, which is negative 2. So altogether we're left with negative 2 secant squared of u du. And then secant squared antiderivative is just going to be tan of u. So this is going to be negative 2 tan of u plus c. And now we can go back and substitute in tan of negative 5x for u. So we get the very interesting looking answer of negative 2 tan of negative 5x, all of that plus c. To take the antiderivative of this expression, we have to recognize that we have this inner function whose derivative, something involving an x, is elsewhere in the problem. So it'll help if we start by letting all this stuff inside here equal u, and then integrate this by substitution. So our next step then, we're going to take the derivative of both sides of this. So we're going to have du equals, and this would just be 1 over 5x times a tail of 5, so 1 over x dx. And then we can say dx equals x du. Substituting back into the original, we have 4 radical u over x, and then we have x du instead of dx. X's are going to cancel, and I can just rewrite this as 4u to the 1/2 power du. Using the reverse power rule now, this bumps up to a 3/2. Multiplying by 2/3, we have 8/3 u to the 3/2 power plus c. And then I'll just substitute this 4 plus ln of 5x back in for u. For this one, I notice that I have this inner function, 3x to the 4th plus 1, whose derivative, which is going to involve an x cubed, is elsewhere in the problem being multiplied. So let me start by setting all this stuff equal to u and trying some u substitution. So then the derivative of that stuff, we're going to have du equals 12x cubed dx. And then we can divide by 12x cubed to get dx by itself. Substituting all that back in, we have negative 36x cubed times the sine of u. And then instead of dx, we have du over 12x cubed. The x cubes are going to cancel. Negative 36 over 12 is negative 3, so we have negative 3 sine of u du. Antiderivative of sine of u is negative cosine, so this comes out to positive 3 cosine of u plus c. And then we'll plug the 3x to the fourth plus 1 back in for u to get our final answer. For this problem, I happen to notice that this 5x to the fourth plus 1 is an inner function whose derivative, involving an x cubed, might be somewhere else in the problem. So let me start by doing a little substitution here. Maybe I can integrate it that way. Let's start by setting all this stuff, 5x to the fourth plus 1, equal to u. And then if I take the derivative, I can say du equals 20x cubed dx. And then I'll divide by 20x cubed to get dx by itself, so I can swap it out later on. Plug in stuff back in. We have 80x cubed over u to the fifth. And then instead of dx, I have du over 20x cubed. X cubeds are going to cancel. We have 80 over 20, which is just 4. So we have 4 over u to the fifth, which I can rewrite as 4u to the negative fifth with a du after it. And now using the reverse power rule, this exponent bumps up to a negative 4. Dividing by that, I have negative u to the negative 4 plus c. And then let me substitute 5x to the fourth plus 1 back in for u to get this final answer. For this one, we're just trying to take the antiderivative of this crazy looking expression. So one thing to pick up on in this one is I noticed that we have this inner function whose derivative might be something that matches this other piece out here. So I'm going to try u substitution, and hopefully I can cancel out some stuff when I do that. Let me start by letting u equal x cubed plus 3x minus 5. And then if I take that derivative, I have du equals 3x squared plus 3. And then we have a dx out there that we don't want to forget about. So now to isolate dx, I'm just going to divide both sides by 3x squared plus 3. And now it's time to do some substitutions. So back at the original, I'm going to replace all this stuff in here with just u. So I have u cubed down there. And dx, I'm going to swap that out for du over 3x squared plus 3. And at this point, notice how I actually, while I did that, factored a 3 out of there. So this makes it something that I can actually cancel out with the x squared plus 1 that's already there. So those are going to cancel. I've got 1/3 u to the negative third power, du. And now using my reverse power rule, this is going to bump up to a negative 2. Dividing by negative 2, I have negative 1 over 6 u to the negative 2 plus c. And at this point, I can substitute all this stuff back in here. Now, when I do this, I could write all of this stuff to the negative 2 power, or I could write 1 over all of this stuff to the positive 2 power, which is what I did here. Why did I do it that way? Well, so that it matches one of these answer choices, because that's what they did in all the answer choices. So taking a quick look, it appears to be choice D. For this problem, they're giving us the substitution u equals 5x minus 2, and they want us to rewrite this integral as, well, one of these down here. So let's start with the step that they gave us, u equals 5x minus 2. Okay, well, if we were doing a u substitution, our next step would be to take the derivative of this thing. Ultimately, we need to get rid of this dx and replace it with a du. So when I do take this derivative, I get du equals 5dx. And then if I divide by 5, I can get dx by itself. Substituting back in here, we're going to have integral of x times the square root of u, or u to the 1/2 power. And we also have du over 5. Now, this doesn't match any of the answers here, and I mean, really, we shouldn't be happy with this because this x isn't going to cancel out yet. So to get rid of that x, we actually have to go back to this equation here, u equals 5x minus 2, and we have to rearrange this so that we isolate x. That will allow me to swap out a single x for something involving a u. So if I get x by itself here, I can say x equals u plus 2 divided by 5. And swapping that back in for this singleton x here, I've got this crazy looking expression. Still doesn't quite look like any of these, so we have to massage this a little bit. I notice that I have a 1 over 5 over here and another over 5 here. I can actually take those out as a 1 over 25 out in front. And inside now, really, I just have u plus 2 and this u to the 1/2 power. I can distribute this u to the 1/2 to get u to the 3/2 plus 2u to the 1/2. Still have a du in there. And does that match anything? Well, this one has a 1 over 25, and it looks like it's got everything else too. So choice D. For this one, we're taking the antiderivative of this crazy monstrosity. Let's go ahead and see what we can do here. Now, the key on this, I notice that I have this inner function. So since I'm doing a composition, U substitution is a good bet on this. And if we look a little bit closer, if I took the derivative of this, I'm probably going to get something with a sine and or a cosine. So let's go ahead and let u equal sine squared of x plus pi and see what happens with that. So then du is going to equal, well, let's see here. I need a chain rule. We're going to have 2 times sine of x times the derivative of sine, which is cosine. We have a dx there as well. This pi is just a constant, so that just becomes 0. And now if I want to isolate dx, I can divide both sides by 2 sine of x cosine of x. So now plugging stuff back in, I can write sine of x cosine of x times e to the u. And instead of dx, I'm going to have du over 2 sine of x cosine of x. Well, that conveniently cancels out the sine and the cosine up here. So we just end up with 1 over 2 e to the u du, whose derivative is 1/2 e to the u plus c. And to match the answer choices, I have to plug sine squared of x plus pi back in for this u to get this expression here. And that's going to be, let's see here, looks like, is that answer choice C? Yep, positive instead of negative 1/2. Choice C. On this problem, we're given the integral of cosine of 4x sine to the 5th of 4x dx. We want to know what that's equivalent to. So they have a few different things going on here. Firstly, we have this weird expression in b where they're just splitting up this integral with multiplication, but that's not one of the rules of integrals. We know that we can't do that, so b we can just eliminate right off the bat. Other choices now, it looks like all the other choices involve having a u substitution. So let's try the u substitution game on this. The inner function whose derivative is somewhere else, well, sine is an inner function, specifically sine of 4x. And the derivative of sine of 4x involves a cosine of 4x. So I'm thinking it's probably going to be choices C or D. Let's let u equal sine of 4x. And really then it just comes down to what we end up with if we follow that path. So u equals sine of 4x. That means du equals, this is going to be 4 cosine of 4x, using a little chain rule there. So then du over 4 cosine of 4x is the same as dx. Plugging stuff back in, I've got cosine of 4x, and now we're going to have u to the 5th. And instead of dx, I've got du over 4 cosine of 4x. Well, these cosine of 4x's are going to cancel, so that just leaves me with 1/4 u to the 5th. And I can take that 1/4 outside the integral if I want to. Now, it looks like that's going to give me answer choice C. We don't have to actually go any further. We're just going to stop there.